Hello students, welcome back. So in today's session, we'll discuss about introduction to states of matter. We'll discuss about the basic concept of matter like solid, liquids and gases. We'll differentiate them and afterwards we'll discuss about the properties which are used to measure your different states of matter. So let's start with our part. Introduction. So in introduction, first point says that matter can be classified into three categories depending upon its physical state, right? All the concepts now related to your states of matter depends on this first point, that my matter is classified into three different states. What are those states? The states are solids, liquids and gaseous states, right? So what is the governing factor? The governing factor is the physical state. So what is the physical state of a solid? Solids have a definite volume and a shape. Liquids, they have a definite volume but no definite shape. Yes, this is very important point. So what can I say? I can say that liquid always takes the shape of a container. So you can take any container, right? Liquids always take the shape of the container. So they have a volume, right? Yes, you can measure the volume of the liquid, but when someone asks the shape of a given liquid, you will obviously say the shape of the solid in which the liquid is filled in. And when it comes to the gases, they do not have a definite volume and they do not have a definite shape. So I have classified and I have differentiated in a unique manner so that you can understand. So solids, the first point itself says that particles are very closely packed. Yes, you can take this pen which is a solid, and in the solid all the particles which are present are tightly packed. That means, are there any voids? Yes, even in the solids also there are certain voids, but the voids are extremely small. But when I take a liquid now, what are the liquids? In liquids, the particles are loosely packed when I compare to the solids. Even in liquids also the particles are packed. But remember, the particles which are packed are loosely packed. And what is happening to the voids? Yes, even there are voids in the liquids, but the voids are now larger compared to the voids which are present in the solids. Next, what happened to the gases? Gases, right? They are very loosely packed. You can see that air which is an example of a gas, right? All the particles are loosely packed, right? The intermolecular distance between these molecules is very poor. So what is happening when intermolecules are very poor? Even you can find voids. So my voids are very large. So you can see here, yes, in solids my interparticle forces are very large, and in liquids my interparticular forces are intermediate. Intermediate to what? Intermediate to your solids and gases. And in gases my intermediate forces are negligible, right? I told they are very poor. That means they are negligible. And this is an interesting point. So the particle motion is restricted to vibratory motion. I mean, when I consider a solid, obviously there can be motion in all the three states, right? There can be motion in a solid, there can be motion in a liquid, and there can be motion in gas. But my particle motion in a solid is always restricted to a vibratory motion. That means only particles can vibrate only. Next, in liquids, yes, there is a particle motion, right? Liquids flow. You take a water and you pour that water on the floor. You will see that if the floor is slanted, the water flows. Why? Because here the particle motion is there, but it is slow. What happens to the gases? Yes, by this time you would have understood, right? Yes, my particle motion is rapid. The gas particles are randomly moving here and there in the container or in the atmosphere. Their movement is random. So the particle motion is very rapid and also very random. So these are the Now these are few important distinctions between your different states, that is solids, liquids and gases. Now we will come on to the core concept of gases. So first we'll start with the basic concept. What are the measurable properties of these gases? So the important properties of gases are your mass. Yes, gas molecules have some mass. Your volume. Yes, gas particles are alright. Gas particles are moving here and there, right? So that means they have certain space to move, and that space which is available to move is nothing but it is the volume of the container in which these gas particles are present. These gas particles are present. For example, you consider your room now, right? These gas particles in your room are moving randomly here and there. But what is happening? They have certain space. And what is the space? The maximum space available for these gas molecules. The maximum space available for these gas molecules is nothing but the volume of the container. It's nothing but your volume of the container. That means, yes, my volume is an important property of the gas. Now temperature. Temperature, in the starting itself I told you that temperature is affecting my velocity. That means temperature is affecting my kinetic energy. So I can say that my temperature is an important property, and it is not only important property, it is a dynamic property. So how, with the help of a temperature, when you are changing the temperature, how my property of a gas is changing. So we will be discussing about them in detail. So what is mass? We will start with the first property of the gas. What is mass? Mass of the gas is nothing but it is related to the number of moles. What is mole? Mole is nothing but the amount of substance present in Avogadro number of particles. What is Avogadro number? Avogadro number is Na, which is 6.023 into 10 power 23. So the amount of substance present in these many particles is nothing but the mole, right? And what is the mass of gas? Yes, mass of gas is related to this number of moles. How? Yes, N is W by M. What is W? W is nothing but the weight of the gas. And what is M? M is nothing but the molecular mass of the gas. So number of moles is related to the mass of the gas, and you should also know the molecular weight to calculate the number of moles. And yes, N is the number of moles, W is the mass of gas in grams, M is the molecular mass of the gas. What is volume? Volume I already told you, since gases occupy the entire space available to them, right? I told you, I gave an example of the gas particles in a room. They occupy the entire space. So that means gas volume is nothing but what? The volume of the container itself, container in which the gas molecules are enclosed. So the gas volume means the volume of the container in which the gas is enclosed. Now, what are the different units of the volume? So units of the volume, you can see here there are different units, right? For example, volume, the same volume is expressed in meter cube, the same volume is expressed in liter, the same volume is expressed in decimeter cube, and the same volume is expressed in centimeter cube. That means volume is measured in different units. And yes, are all the units important? Yes, all the units are important, because generally you can see that meter cube is the SI unit but not the liter. But liter is also one of the unit and a very important used unit of volume. So you have to understand how to convert my meter cube into liter. So when I am talking about a meter, obviously I will talk about what? I will talk about centimeter cube. So you should also know how to convert my centimeter cube into liter, right? So this is the relationship between different units of volume. That means my 1 meter cube is equal to 10 power 3 liter. That is nothing but 1 meter cube is nothing but 1000 liter. That is nothing but 1000 decimeter cube and 10 power 6 centimeter cube. So it is very important to know this relationship between a meter cube and liter. And yes, if I know liter, right, I can know how much ml is present, right? Generally, you will see that ml, which is a unit of volume, also plays an important role, right? And 1 liter is 1000 ml. So ml is also an important unit of volume. Next, pressure. Pressure is also one of the important property of gas. What is pressure? Pressure is nothing but it is the force exerted, and when this force is exerted by the gas per a unit area, I mean pressure depends on not only force but also area, right? So for example, you consider this piston. So what is the pressure? If you consider there are gas molecules, it is nothing but the pressure exerted by, the force exerted by this gas molecule on a given area of the wall. For example, consider this area of the wall. So there is a force, and this force exerted on this given area is nothing but the pressure exerted. So when I talk about the pressure, I will also talk about what? I will also talk about my area. So what is the total pressure exerted by the gas molecules in this container? It is nothing but the force, the total force of the gas molecules, and the total area of this container or total area of this wall. So what are the different units of pressure? The different units of the pressure are nothing but your atm, your pascal, your bar, and your lb per inch square. And what is the important conversation? The important conversation is nothing but 760 mm will be equal to 1 atm will be equal to 10132.5 kilopascal or 101.325 pascal. So you can see the same units. So, but remember this very important thing, 760 mm is equal to 1 atm is equal to 1.01325 bar is equal to, this is 1032.5, this is 101.325, so it is nothing but 101.325 kilopascal. So you can see that what is 760 mm? It is the height of the mercury column. What is atm? Atm is the important unit of the pressure. What is bar? Bar is also one of the important unit of the pressure. And what is kilopascal? Kilopascal is the SI unit. So it is very important to understand how my different units of pressure are interrelated with each other. That means here my mm is related with atm, atm is related with bar, and bar is related with kilopascal. So these are the important measurable properties of your gases. So in this you will actually learn about the differences between your in this part you will learn about the differences between your solid, liquid and a gas. Next you will learn about the measurable properties. So you have also learned the important units, right, and the conversations. This is very important. Generally most of the students gets confused in the application part of the unit. So I suggest you to remember this conversation between the different units of the volume and also this table, because the application part, when you come to a numerical, the numerical generally depends on the unit, right? The answer of the numerical generally depends on the unit and the value of the unit. So these two units gives you an idea about the different conversations of the same volume and pressure. Next, temperature. Temperature, no need to think so much, because there are only two units generally applicable in gaseous state. One is what? One is your degrees and one is your Kelvin. Unlike 4-5 units in volume and pressure, temperature is having just two units. What is degrees centigrade and other is Kelvin. So what is the temperature? What is the definition of the temperature? Temperature is nothing but it is the degree of the hotness of any given body, right? If I heat this pen, and that means this pen becomes hot, and if I measure how much hot it is nothing but I have to use the term of temperature. So temperature, it is nothing but it is defined as the degree of your hotness. So what is the SI unit? The SI unit is the Kelvin. But generally we talk about degrees, right? When we talk about temperature also, you will talk as 25 degrees centigrade, the room temperature for example, or the weather telecast, the weather forecast, it's also defined in terms of degrees, right? 25 degrees temperature, when it comes in winter it is 3 degrees temperature, 2 degrees temperature. But now you have to understand how to convert this degree centigrade to Kelvin, because my SI unit of temperature is Kelvin, and that's why I have to define my temperature in Kelvin. So what is the relationship? Now you should have a relationship, right? Just like you have different relationship between the units of volume and pressure, you should also have to understand how to relate between the different units of temperature. How? Because for example consider 25 degrees centigrade. So 25 degrees centigrade is nothing but 273 degrees plus your 25. This is the value in Kelvin. That means 273 Kelvin plus your degree centigrade value. For example, here it is degree centigrade value is 25, right? So it is the degree centigrade value. So this will be your relationship between degree centigrade and Kelvin. For example, water freezes us 273 Kelvin, right? That means 0 degrees. So 0 degrees is nothing but 273 Kelvin plus your unit, your value of the unit of degree, that means 0 Kelvin. So it is nothing but 273 Kelvin itself. And 100 degrees centigrade. So what is 100 degrees centigrade? 100 degrees centigrade is the boiling point of the water. So it is nothing but 273 Kelvin plus 100 Kelvin again. So it is 373 Kelvin. So on a Kelvin scale, water freezes at 273 Kelvin and boils at 373 Kelvin. So this is the end of the first part, that is nothing but the introduction of your gaseous state. So in this topic we learnt about the basic concepts which are very useful. For example, even though either you consider the unit conversation, either you convert, either you understand the differences between solids, liquids and gases, all these basic concepts are very useful for the further parts. The application of the further parts starts with this basic concepts. So students, these are the important basic terms which are used in gaseous state. Remember one thing students, we have seen about the different units of pressure, volume and temperature. Most of the students confuse between the term or the unit which you have to use while calculating a numerical. So make sure you're understanding the basic units which you have to use while calculating a numerical. So go through that many times, go through the recording many times and make sure you're confident with the units which are used in solving a numerical. So in the next part, we'll discuss about some more interesting topics or interesting terms or interesting laws, gas laws. So till then, goodbye, take care of yourself students. So bye.